Okay, welcome back. Intro to Technology 1023. We're going to go over computing history today. This is one of the things that we need to ground ourselves with in terms of where we came from and really start to realize that the field itself is relatively immature, still progressing, and we still need to converge on solutions that work. Um, so yeah, the best way to do that is to see where we came from and see where we are right now. And then we can extrapolate a little bit and look to see what is in the future. All right, computing history, 30s. So this is essentially where I draw the line of where computing history actually started. There are some people that say mechanical computing devices like calculators were the first computers. That seems a little bit on the ridiculous side to me, but yeah, it just depends on how you draw the line and define these things. So the way I define it is with electronic logic, right? So Bell Labs created a Boolean logic with relays in 1937. So this is obviously a very primitive computer, but this is something that represents what we see today using electronic logic to perform something. All right. 1939 was the founding of HP, Hewlett Packard. First product was a audio oscillator. Random thing, not really even computing. Okay. Zeus C3 used for aerodynamic calculations. Okay, and one of the trends that you're going to see quite a bit here is that these early computers are all hyper specialized, and that is true even today. So all your bleeding edge technologies are all going to be hyper specialized, one off, experimental, trying to push the industry forward type of devices. They're not general consumer. It will never be Apple that produces a thing that is truly groundbreaking. All right, so one of the things I do want to point out here, and it's relatively popular to do so, is all of those round looking things in the picture off to the right, those are vacuum tubes. So up to this point in early computing, we were very reliant on these vacuum tubes for electrical processing, and that didn't change until the transistor. And I'm going to have a special call out when that actually happens, because that is the turning point for what we understand computing to be today. Okay, so we have Bombi in 1942, decrypting German communications. Okay, so war, that's another theme that you're going to see throughout here, that war, government agencies typically are the ones that are putting the money forward to push this technology forward. Okay, Colossus in 1944, again, more deciphering. 1945, first draft of the store, electronic information. Okay, so up to this point, everything has been one-off and hyper-specialized, but one of the things that we haven't been able to do at this point is to be able to store this information any long term. So this is the first call out of a experimental theoretical way of possibly handling this problem. Okay, 50s, again, still a bunch of hyper specialized devices. Nothing on this page really worth calling out. It's just more of the same and just applying these technologies a little bit differently. And this is where the turning point happened. So the invention of the transistor made computing smaller, faster, produce less heat, and cheaper. Right. So at this point, it just makes everything easier. And then rapid iterations on top of that. This is where you really start to take off. And a lot of people think, when they think computers, this is kind of what they think of. The early 60s, early 70s, when this really started happening, but it was back in I believe it was in the 50s, transistor was made. And this is the true turning point for computing. Okay, 1960s, IBM 7000 series, so mainframe computers, very, very similar to what the cloud is today. Not exactly the same, the concept's a little different, but in terms of where everything is stored, where all the processing is happening. It's very similar to a mainframe concept. Okay, and then the Programmer 101, first programmable calculator. Okay, so you take that storage concept from before and you add some transistors, and now you have a portable calculator that you can program yourself, and it stays that way, which is up to this point hasn't been a thing. Okay, 1972, parallel processing. Okay, so something that we've gotten very used to up to this point, and we didn't get parallel processing on the consumer end until, Athlon, so like 2003, 2004, so relatively recent that we got it on the consumer side, but parallel processing has been around for a long time. Bill Gates, Paul Allen licensed BASIC. So BASIC is a programming language, and apparently in 1975. A lot of things were written in BASIC. Not so much anymore, but yeah, don't know what to say there. 1970s, Apple I by Steve Wozniak. Okay, so this is kind of where Apple came onto the scene. And if you don't know the history of Apple, I'll give you a brief overview. Steve Jobs and Steve Wozniak paired up to create Apple. Steve Wozniak was obviously an excellent engineer. Steve Jobs, everyone knows for the business and innovative aspect of it. Wozniak did most of the work though. So don't know what else to say there, but you need a team, right? Those demeanors are very, very different. Atari, 1979. Right, that's a big one for at least most of the older generation here. Okay, 1980s, BBC, the computer program. Okay, so this is the public trying to learn about this thing, and agencies like the BBC and America had something similar about this time as well, trying to teach the public about computers. And more than likely it was about advertising for people to actually buy these things. But I don't know what else to say there besides it takes legitimate time and effort for something that is truly unique and innovative for the public to take notice and actually care, because Steve Jobs actually is quoted saying this, that you need to tell people what they want, they won't tell you. So, and I don't think it's a coincidence that the next year Commodore 64 came out in 1982, which is pretty iconic as a computer. I don't think there's a coincidence at all. It does seem to be advertising there. So sold 22 million units. Definitely not bad for 1982 and no one caring about computers. Okay, IBM was a player in this space as well. Okay, Macintosh, 1984. IBM released RISC in 1987. Portable Macintosh, so your first laptop, is going to be in 1989. Okay, so in the 80s is when we started getting consumer products, but up to this point, let's say the 40s is really when we started getting computers to do work for us and automate work for us. It took about 40 years for the consumer market to get something along those lines. So keep that in mind when you start thinking about bleeding edge tech. So something like DNA storage, so DNA based digital storage. There are prototypes out there that sort of kind of work. The chances that we're going to get that in 10 years is pretty low. 40 years, maybe, right? We're talking that type of timeline. Okay, computing history, 1990s. So if you're about my age, this is your generation here. And you remember these things. I remember this iMac being colorful. And basically the only reason why I wanted it was because of the colors. But I was also a kid, 5, 6, 7. But maybe that was the point for Apple. So Newton, from Apple, 1983, first handheld computer. Okay, so not quite a cell phone, but it is just a portable computer if you needed that. Palm Pilot, very similar. IBM ThinkPad 701C. So the IBM in general, which is now owned by Lenovo, uh, one of the first business laptops that was reliable, good, portable. It was very, very popular for the time, and in a lot of ways, it still is. Um, and the style of it, iconically at this point, has not changed, not really. Okay, computing history in the 2000s. So this is getting into the realm of what most people are familiar with. The first phone, first camera phone, Sony J phone. Okay, that's a thing that happened a long time ago. Power Mac G5, Arduino in '05. Okay, one laptop per child policy. That was '06, and that was when I was in high school. I remember when that happened. Lenovo acquires IBM, as I stated before. Amazon Kindle, 2007. iPhone, 2007. MacBook Air, 2008. Okay, so these are all the devices that you're starting to get used to and that you've been exposed to. Okay, Apple's Retina content in 2010. Okay, Nest was 2011. Doesn't seem that long ago that we had AI-based devices. But yeah, it was 10 years ago already that we had them. So iPad 11, 12 for Raspberry Pi, 15 for Apple Watch, and then AMD Ryzen 2017. So again, the computing industry definitely moves fast, but if we're talking fundamental changes in how things are done, it takes a long time to make that consumerable, make that where consumers can actually buy it. Okay, so up to this point, we've been talking about computer hardware for the most part. We haven't talked a whole lot about concepts, and in particular, networking. So networking, we haven't covered in this course yet, but networking as a concept is just the ability to connect computers together and share data. So traditionally speaking, most people think of the internet as this, and it's correct. It just didn't start that way. It started as, again, another government agency because we needed to make sure that our data and our encrypted files are shared between resources, in this case, bases or forts. And we had to do that without sending carriers and mail, which obviously can be intercepted. So the networking history aspect of it, why it came about, was because of war, because of communication. ARPANET, which is some of the first packet switching based networks, and that was 1969 when that started coming up. I don't know. Yeah, I don't know what else to say there. Again, there's a bunch of trends happening here, going mostly government agencies pushing this technology forward, and it's almost always because of war. So say what you want about war, we tend to get good technology out of it. All right. So the rest of the information here are little milestones that keeps happening. So call out for Ethernet through Xerox. I haven't really called out Xerox a whole lot yet. Xerox used to be a prominent player in the technology space. They're not so much anymore, mostly just bad business policies. But yeah, they came up with the first iterations of a GUI, first iterations of a mouse, laser printers. I think they came up with the digital camera as well, right? Yeah, Xerox did a lot. Yeah, bad business policies. You're on top for a while and didn't really come back from it once you fell. So what I do want to point out here is the Ethernet standard was created by Xerox in 1973. Ethernet has been around for a long time, a very long time. Okay. VoIP call. So voice over IP is what that stands for. So this is a digital call over the internet. 1973. Now, to be clear, again, back to trends. back to the trends of the market, VoIP was 1973. You can get a VoIP phone now, and it's popular for businesses, and that became popular by late 2000s. So that took 30 years to get to market for businesses to actually buy it. And then we're getting phones now for like home phones if you actually need one, and you end up using a VoIP phone. So that took 40 years to get to consumer market. A little bit because we had technology already that served that function. Other parts is just because it takes a while for these things to make it to market. Okay. First network router, Xerox, 1973. Again, Xerox again. First IP router, 1976. All right. So a bunch of things happened in the 70s, and rapid iterations of these really pushed the networking aspect of this forward very, very quickly through the 80s, which is this. So TCP is what we still use today. It was created in 1978, DNS 1983, so domain name server. So this allows us to have the ability to type in something like google.com where we don't have to remember an IP address. Waveland network, okay. AT&T, Lucent, and NCR. AT&T is also a relatively big player, particularly with the operating system space, which we'll go over. Well, actually, I think we already went over it. Yeah, so there's a lot of companies here that put a bunch of time and money into this concept that we call networking and computing. First networking firewall, 1988. Okay, IPv6, 1996. And that took 20 years for us to actually take that seriously. Okay, your first Wi-Fi standard, so 802.11, your first Wi-Fi standard, 1997. So while people were still on dial-up, we had Wi-Fi. All right. And we'll talk about, if you're an Alfred Stage student, we'll talk about Wi-Fi a little bit more in class, just because we need to make sure that you understand what Wi-Fi actually is. Because a lot of students coming in are thinking that Wi-Fi equals internet, and that's not correct. Okay, web. First Wi-Fi encryption, 1999. That got broke almost immediately. It was not very good. WPA 1 and 2, 2003. Much better. It was around for a long time. WPA 3, 2018. So yeah, it took a long time to get WPA 2 to be broken, and then WPA 3 I don't think has been cracked yet. So that brings us up to current, but notice that what I want to point out here is that the networking history, most of it happened in the 70s and 80s, and then it was just iterations on things that we already knew. Networking in general, if we're talking about relative to other fields like software programming, moves much slower. Is much more procedural oriented. So if you are a first stage student, you don't necessarily know if you want to go into the networking field or the software field. Basically, that comes down to how much learning do you want to do. If you don't necessarily like the rapid turnover, but you like the concepts, networking's typically a little bit better. If you like creating things from scratch, creating things that did not exist before, software is better, but you're going to have to learn more because it changes so rapidly and it keeps getting faster, particularly if you're in web development. Okay, so James Gosling, so one of the original Java developers, primarily in the 90s, but you can watch this video on your own time because I don't want to get copyright. All right. So with that said, that's going to conclude networking history and computing history in general. So key takeaways here is that there is rapid innovation, there is rapid turnover, there is rapid change. It just takes a long time to get to consumer market, and the things that people would claim, especially normal people would claim, is just technology oriented. They just don't understand how the system works and where we came from and what fundamental changes, what that actually means. Because up to this point, for most of your things, they're not fundamental changes. They're just reimaginations of taking the same concepts and then just moving them around to achieve a different thing. The difference between a Arduino and a cell phone is relatively small. It's almost all software based, right? Um, but the difference between, again, DNA storage and mechanical hard drive storage, or even SSDs at that point, they're all very different from each other. Those are fundamental changes. Um, and those fundamental changes take a long time to develop. So I really want to nail that home as one of the primary takeaways. And I will conclude this little lecture here. So I'll see you in the next one.